This is a video lesson on exponential growth and decay. So we're going to be looking at the growth factor in an exponential function. So when we're talking about growth or decay, there's a formula that we can use to find that. And what we're going to have is 1 plus or minus r. And that's going to give us our growth factor. Now we're going to add 1 plus r when we're growing, 1 minus r when we're decaying. So if I have, let's say I have a bank account that has $500, so $500, and it's going to grow at a 4% rate, that would be 1 plus 0.04, or 500 times 1.04 to the x. And this would be a rate of 4%, or 0.04. Another situation would be where I have a vehicle that's going to decrease. Let's say I paid $10,000 for it, and it's going to decrease at a rate of 6%. That would be 1 minus 0.06. So when I look at that, that's going to be times 0.94. So my B will be 0.94, and this is a rate of 6%, or 0.04. So if I'm looking at an equation that looks like this, y equals 2 times 1.3 to the x, I know that this is growth, and the rate is going to be this 30%, or 0.3. If I have an equation that looks like this, y equals 2 times 0.98, I know that's going to be decay because that b is less than 1. And what I have is 1 minus r equals 0.98. Well, if I solve that equation, this r would be 2%. So r equals 0.02. So the rate is 25%, or 0.02. So when we're looking at the exponential equation, we know that a is the initial value and b is the growth factor. And again, b is greater than 1 would be growth. B less than 1 would be decay. So looking at exponential growth from a table, we know that x is going up 1 each time, and we are multiplying by 4 each time. So b is going to equal 4. So in my initial value, I'm going to find where x equals 0. So then the equation for this function would be y equals 2 times 4 to the x power. Now exponential growth from a graph is going to go up. And we know the initial value is where it crosses the y-axis. So a here is going to equal 5. And if I'm looking at my points, to get from one to the next, this to this, I have to multiply by 2. So b is going to equal 2. So y equals 5 times 2 to the x power. Now in a real world example, I've got $4,500, so that's my initial value, in an account that pays 5% interest, and it pays So this is going to grow. So this is going to be times 1.05 to the x power. And the reason for that is that 5% as a decimal is 0.05. And I know that because it's growing, it has to be greater than 1. So it's going to be 1 plus 0.05. So my growth factor is 1.05. Now we're going to look at exponential decay from a table. And for decay, we know that b has to be less than 1. So I'm going up 1 on my x, and I am multiplying by 1/3 or dividing by 3. Now looking for my y-intercept, it's where x equals 0. So the equation here is going to be y equals 9 times 1/3 to the x power. And if I were looking at this equation, I can tell that it's decay because that b value is less than 1. Exponential decay from a graph, you're going to know that it's decay because it's going to go down from left to right. We're going to look for where x equals 0. So our a value is going to be 4. And to go from left to right and get from one point to the next, on the y-axis, to get from 8 to 4, we have to multiply by 1/2. So our b value is 1/2. So y equals 4 times 1/2 to the x power. Again, we can tell that's decay because 1/2 is less than 1. In a real world problem, we have a car that was purchased for $18,000. So that's going to be my initial value. And the car depreciates by 20%. So that's going to be 1 minus 0.20. So my b equals 0.8. I do 1 minus because it depreciates or it's decaying or going down. So that's y equals 18,000 times 0.8 to the x power. So just remember that if you're given a rate of growth, if it's going up, it's 1 plus the rate. If it's going down, it's 1 minus the rate.